Hello everyone and welcome to a new video where I'm going to be taking up a problem from functions, a very important part of calculus, and this is a very good question with a very elegant solution. Although the answer does look a little trivial for some people, but we are going to be diving into the proof of how we got to that answer. So make sure you give it a try before watching the solution. Let's start. We are given this condition that f of 2x minus f of x is equal to x for all x belonging to real numbers, and we have been given a condition that f of 0 is equal to 1. We need to find all continuous functions from real to real numbers, right? The idea that comes to my mind here is to eliminate 2x, and we can do that by replacing x with x by 2 because x belongs to a real number, so we can replace it with any number. That's the first idea that comes to my mind. So let's replace it. When we replace x with x by 2, we'll get this x by 2, and here also we'll get x by 2. Similarly, if I replace it again with x by 2, we'll get f of x by 2 minus f of x by 4, which I can write as 2 square, and this also will become x by 2 square. Notice that the LHS is something like a telescopic sum and the RHS is becoming a GP, which is actually good for us because things can get simplified. What I'm going to do now is let's take it up till some end term, right? So that it becomes easier for us to generalize. And when we do so, we'll have something like f of x by 2 to the power n minus f of x by 2 to the power n plus 1 is equal to x upon 2 to the power n plus 1. And now if we add everything, we'll get something like this. Like basically everything here on the LHS is going to get cancelled except two terms, which is f of 2x minus f of x by 2 to the power n plus 1 is equal to, now if you see on the RHS, we can pull out x from every term and we can write it as 1 plus 1 by 2 plus 1 by 2 square all the way up to 1 by 2 to the power n plus 1. Now think about it. We are remember that we have been given a condition that f of 0 is 1, as you can see. So what we can do here is we can try to get f of 0 somewhere to simplify things further and get rid of that n part, right? If we are able to get rid of n, we will be able to get rid of majority of the things. And luckily in this question, if you get rid of n, you'll be able to get rid of this whole term. And if you get rid of this whole term, you will be able to get f of x very easily. Right. So how about we put n approaching to infinity on both the sides? If we do so, what will happen here is this term x by 2 to the power infinity would be somewhere would be approximately 0. So we'll get f of 2x minus f of 0 is equal to, now this will just become an infinite GP, and we know how to solve it. This will become x into 1 upon 1 minus 1 by 2, right? So now what we get here, after simplifying the things, we'll have something like f of 2x minus f of 0 is 1. So we'll write it as f of 2x minus 1 is equal to x, and this will become 1 by 2, so it will become 2x. We get f of 2x equals 2x plus 1, and we need to find f of x. So f of x will just be x plus 1. And this is the answer that we have gotten. And yeah, this will be the only solution for the question. This will be the only function that satisfies all these conditions given. So a very tricky question. If you don't get the idea of it, you'll be stuck in the trap of it. And I have shared the idea of how to go about it. The idea here was to first get rid of 2x, replace it with something. Then I saw that there's something telescopic being made, so I tried to generalize it. I saw a GP on the RHS. I saw a telescopic some kind of thing on the left. Then I tried to get rid of 2 to the power n plus 1. I knew that f of 0 is 1, which is given, so I tried to get 0 somewhere. I got it here, and we know how to solve the infinite GP. So that's how we got to the solution that f of x is equal to x plus 1. I hope you enjoyed the solution, and yeah, I'll meet you in the next one.